Hello everyone, welcome to Infinity Learn by Sri Chaitanya. I'm Ravindram and today I'll be discussing the physics portion of your AIIMS paper happening last weekend. Okay, so let's have a look into the first question. The density of a cube is measured by measuring its mass and length. Okay, what is a cube? The volume of the cube is L cube, right? Density is mass per unit volume, that is mass upon L cube. So density is m1 L to the power minus 3, right? We can write like this. So what is delta rho upon rho? It is delta m by m plus errors are always added 3 times delta L by L. Now you can put the values and get the answer. Okay, so delta rho by rho percentage wise will be percentage error in the mass, that is 3 percentage, plus 3 times percentage error in the length, that is 2 percentage, that is overall 9 percentage. Fourth option is correct. Okay, second is the coordinates of the center of mass of the particles. Okay, so 10 grams, 20 grams and 30 grams, they will together become a mass of 60 grams whose center of mass is located at vector r1, which is equal to I cap plus j cap plus k cap, right? And the position, another mass is m2 is 40 grams and whose position vector is r2, we don't know. And the center of mass of this complete system is origin. Okay, so it is 0 I cap plus 0 j cap plus 0 k cap, that is a null vector, right? So we will say rcom is equals to m1 times vector r1 plus m2 times vector r2 upon m1 plus m2. So from here you can say RCOM is 0. So you can say vector R2 is nothing but minus of M1 by M2 into vector R1. I hope you can put the values here. So minus M1 is how much? M1 is 60. M2 is what? 40. So it will be 60 by 40, that is 3 by 2, minus I cap minus J cap minus K cap. Okay, so this is vector R2. I hope it is clear. Let's move ahead. A wheel comprises, okay, a wheel comprises of a ring. So ring has mass capital M. So moment of inertia of the ring is mr square. And these are rods of length r only, and they are rotating about their ends perpendicular to the length. So I2 of all these rods will be 3 times moment of inertia of a single rod, mr square by 3. About this end is what? Mr square by 3 and into 3 because there are 3 rods. Okay, so overall moment of inertia will become I1 plus I2, that is capital mr square plus small mr square. Got it? Two blocks of mass is 10 kg and 4 kg are connected by a spring of negligible mass. Okay, so this is 10 kg and it is attached by a spring. So that means the spring force between them will be equal and opposite, and that is why the net force on the system will be overall 0. So hence we can say that the center of mass will not accelerate until and unless an external force is applied. Okay, anyways, so the question is, a 10 kg and a 4 kg are connected through a spring of negligible mass and placed on a frictionless horizontal surface. An impulse gives a velocity of 14 meter per second to the heavier one. So like this is 14 meter per second. The velocity of the center of mass is c. Immediately as you give an impulse here, it will not gain any velocity, right? So we can say velocity of center of mass is m1 v1 plus m2 v2 upon m1 plus m2, right? So it is 10 into 14 upon 10 plus 4. I guess answer is 10 meter per second. Third option is correct. Okay. See, angular momentum needs to be conserved. The value of alpha for which angular momentum is conserved. See, what is vector tau? Vector tau is vector dl by dt, right? So angular momentum is conserved, that means angular momentum is constant, and if angular momentum is constant, then its derivative, that is torque with respect to time, will be 0, right? So if the angular momentum is constant or conserved, torque is 0. Torque is 0 only when vector r is parallel to vector f. Okay, so you can say alpha by 2 must be equal to 3 by minus 6 must be equal to 6 by minus 12, right? So we can take any one. Alpha by 2 is 3 by minus 6, so alpha by 2 is 1 by minus 2, so alpha is minus 1. Got it? Third option is correct. Now, two particles A and B initially at rest move towards each other through mutual force of attraction. Since the force of attraction between them is mutual, there is no external force in the system. So we can say velocity of center of mass will be 0. If it is 3v and if it is v, whatever it is, doesn't matter. Velocity of center of mass will definitely be 0 because there is no external force in the system, right? Because external force in the system is total mass of the system into acceleration of center of mass, so it is 0, right? Now, if energy, velocity and time are chosen as fundamental quantities, the formula, what is surface tension? Surface tension is force per unit length. Okay, okay, fantastic. What is force? mv, that is change in momentum upon time, into L. Now you tell me, what is velocity upon length? It is 1 upon time, so it is t square. Now listen to me, what is energy? Half mv square is equals to energy. So what is m? M is e upon v square, right? So this is equation number 2, this was equation number 1. So we will use it and say surface tension is m by t square. What is m? E by v square t square. Now we can say that E, V and T all have come. So we can say the dimensional formula of S will be E to the power 1, V to the power minus 2, T to the power minus 2. Okay, first option is correct. Eighth question. Okay, what is this? This distance is L by 2, right? So what we want is, and this distance is L by 2, right? And we want the center of mass to be here, where, so that it doesn't fall, the center of mass should be here in this line. And if you see closely, this distance is L by 4, right? And this total distance is 3L by 4. So what is S? S is 3L by 4. The only thing is that this center of mass should be here, because what happens? The overall weight on the center of mass of the two rods must pass through this end point. Do you understand? That is why, because see, because normal will also pass from here and the weight will also pass from here. So the net torque will be 0. But if normal is here and the weight comes here, then what will happen? They both will have a supporting torque and then it will tumble. Okay. Ninth question. Okay, see, if the pipe is open at both ends, then this is how at the fundamental situation displacement of the air particles look like when the stationary wave is established, and this is how the pressure variation looks like, right? So we can say this is a displacement antinode and this is a pressure node. So at the open ends, we get a pressure node. That means pressure change is minimum, not maximum. So pressure change will be maximum at both ends. Wrong. But this is the right statement. Why? Because we want the following statement which is not true. Got it? Now a small object of uniform density rolls up a surface. Okay. There's a surface Okay, and the height of the subject surface they have mentioned is 3u square upon 4g, right? And it is given a velocity v here, and it rotates with an angular velocity omega, right? We don't know its moment of inertia, let's say I. So we will say it's whatever kinetic energy here it has at the bottom end should be all consumed when it reaches the topmost point, because here it is at rest, absolutely, right? So half I omega square plus half mv square will be the kinetic energy at the bottom, must be equal to potential energy at the topmost point. I hope it is clear. Now, very carefully, we will say V must be equal to R omega also. Why? Because it is rolling. So, equation number one, equation number two, we will use. Okay. Now, we want, okay, so omega is what? V by R. Omega is what? V upon R whole square plus half mv square is equals to mg into h is what? 3u square by 4g. Now, after this, you can solve it. You will get IV square by R square, 2R square plus MV square by 2 is equals to 3MV square by 4, right? So on solving this, you will get I is MR square by 2. On solving this, you will get I is MR square by 2, and hence we can call it as a disk. Got it? Clear everyone? Okay, let's move on to the 11th question. Okay, fantastic. Whenever velocity is given as a function of x, then acceleration is v dv by dx, right? So we need to write what is dv by dx. dv by dx is 6x plus 1. And what is v dv by dx? It will be 3x square plus x into 6x plus 1. So this is acceleration. Put x is equals to 1. It is 3 plus 1 into 6 plus 1. So 4 into 7, which is 28 meter per second square. Got it? So third option is correct. Second. A cyclist on a level road takes a sharp circular turn. See, when it takes a sharp circular turn, then who is providing the necessary centripetal acceleration? Obviously, the static friction. What can be the maximum value of static friction? Mu mg, mu n, right? Mu n, and n is equals to mg here. Okay, so we will say that the friction is equals to m AC, and this friction must be less than equal to limiting value. That means MAC must be less than equal to mu n. That means mv square by r must be less than equals to mu mg, which means that velocity must be less than equal to root mu g r. Now put the values. So v must be less than equal to, and if you carefully put the values, okay, root into mu g r. What is mu? Mu is 0.2 into 10, and what is r? R is 3 meter, right? So V is less than equal to root over 6, but this is meters per second, and the options are given in kilometer per hour. So you should know how to convert meter per second into kilometer per hour. Okay, you know that 1 kilometer per hour is how much? 5 by 18 meter per second. So 1 meter per second will be how much? 18 by 5 kilometer per hour. Now you convert and check which of the following options are coming less than the value, less than this value. So V is actually root 6 into 18 by 5, right? Root 6 into 18 by 5 kilometer per hour. This value approximately comes around about 8.8, something like that. Okay, so obviously lesser option will be the first option. So first option is correct. Got it? Okay, this is a repeated question. We have just completed it. 14. Now this is a wonderful question. This is really a wonderful question, students. Here it says that there's a formula V plus U by 2 is V average if acceleration is constant. Number one. Another thing is that delta x is also equal to V average into delta t. Again, if acceleration is constant. So when acceleration is constant, then these are the two things, that we can use. So they have used both these factors in this question. They have asked you, if the average velocity is 40 and the displacement is 240. So first of all, we'll find out the time. 240 is equals to 40 into delta t. So time spent is 6 seconds. So if we say initial time is 0 seconds, so overall time is 6 seconds. So after 6 seconds, what is the final velocity? We don't know initial velocity also. So v is equals to u plus at. So v minus u is equals to a into t. A is 5. So v minus u is equals to 5 into 6. So we can say that v minus u is equals to 30. Okay. Now another thing is, v plus u by 2 is equals to 40. Average is given, and so v plus u is 80. This is another equation. Now what we will do is, if we subtract equation 3 from equation 4, you will get 2u is equals to 50, and u will come out to be 25 meter per second. Got it? So this is how you get the right answer. 15th, obviously these zeros are insignificant. The only significant values are these four: 6, 9, 0, 0. See, the zeros after the non-zero digits is always significant, but before the non-zero digit, if the zero is not sandwiched, then it will be insignificant, right? If this would have been 1.06900, then all of them would have been significant, right? Got it? Next question. Very good. A stationary man. See, velocity of rain with respect to man is equals to velocity of rain minus velocity of man, right? So if I say velocity of rain, we don't know, but it is falling downwards, right? So let's say velocity of rain is Vr times minus j cap, and velocity of man is 12 I cap, right? So let's draw and understand. Velocity of rain with respect to man will become 12 I cap minus or plus Vr times minus j cap. Let's draw it. Oh, not plus. I'm so sorry. Just hang on a minute. It is Vr minus Vm, na? So it will be Vr minus j cap minus Vm is 12 I cap. Now it is okay. Okay. So we'll say that 12 times minus I cap, and this is what? Vr times minus j cap. Okay. So what will be the resultant? You will say, sir, the resultant will be this. Okay. And what angle they have given you? This is 60 degrees. So you can say tan 60 degrees is equals to Vr upon 12. Tan 60 is, acha, with the vertical. 60 degrees is with the vertical. I'm so sorry again. 60 degrees is with the vertical. So this is 30 degrees. So this must be 30 degrees. Okay. So it is 1 by root 3 is equals to Vr by 12. So Vr will be 12 upon root 3, which is 4 root 3 kilometer per hour. Okay. So this is the right answer. Got it? Okay. What is the equation of trajectory? If you remember, x tan theta into 1 minus x by r. Just put the values. X into tan 45 is 1. 1 minus x by r is 240. So y will become x minus x square upon 240. Got it? X minus x square by 240. This is the right answer. Okay, this is a good one. A body is projected vertically up with a velocity of 30 meters per second. It crosses the horizontal line while going up and coming down, and in a time interval of 5 seconds. Okay, let's say t1 and this is t2. then delta t, that is t2 minus t1, is 5 seconds. Okay, let's say the velocity here is u. Okay, let's say the velocity here is, here the velocity is uh, let me take it like this. Here the velocity is v and here the velocity is u. Right? U they have already given us 30 meter per second. If we figure out v, we can get the value of h, right? So what is v? V square is equals to u square plus 2a delta y, right? So v square is equals to 30 square minus 2 into 10 into h, right? So v square is equals to 30 square minus 20h. So this is equation number 1. If we get the value of v, then our answer will come, right? Now we will use this information to get the value of v. See, if you look at this point, v is the initial velocity, it will go to the topmost point and come back. So what is the time it takes to go to the topmost point and come back is 2v by g, that is the time of flight. So delta t is actually 2v upon g, right? So delta t is how much? 5 is equals to 2v upon 10. Okay, so v is 25 meter per second. Now we can put this value. Okay, and we can say 25 square is equals to 30 square minus 20 h. Now you solve it, h will be 13.75 meter. Got it? Now, just remember this thing. Oh, just remember this thing. If an object is here and thrown with velocity v, it goes to the topmost point and comes back in the time 2v by g. Remember this, okay? Now, a uniform sphere density is given. It's kinetic energy. It is rolling, right? It is rolling. So, what is the kinetic energy? It is rotational kinetic energy plus translational kinetic energy. Like this. Now, it's a uniform sphere. For a uniform sphere, what is moment of inertia? 2 by 5 m r square omega square plus half m v square. I guess everything is given, so it will be 1 by 5 m into r omega is v, so v square plus 1 by 2 mv square. So it is how much? 7 by 10 mv square. Now just put the values and you will get the answer, right? Don't forget to convert grams into kg and centimeter into meter. Cool. If you don't forget to do this, then your answer will definitely come out correctly this much. Now let's go to question number 20. See, x is equals to a sine omega t plus phi. That means when we have started observing, the particle is at which position? Or just forget it. Just forget. We use a very common logic. We will say displacement is maximum when x is equals to a. So it is a sine omega t plus pi by 4. It will be cancelled, right? So it will be 1 is equals to sine of omega t plus pi by 4. But when is sine 1? Sine of pi by 2. Minimum value, sine of pi by 2. Right? So from here on comparison, you can say pi by 2 is equals to omega t plus pi by 4. So pi by 4 is omega t and t is pi by 4 omega. Got it? First option. This is a good one. Second overtone of a closed pipe. See, second overtone. First of all, we will write down the formula. For a closed pipe, what are the formulae? For a closed pipe, the formulae are frequency is equals to 2n minus 1 v upon 4l1, right? And for open pipe, the frequency is nv by 2l2, right? Closed pipe is the first one, open pipe is the second one, let's say. So this is the open pipe. Do you understand? Now what they are saying is, what we want is second overtone. See, second overtone means here n should be 1, 2, 3. N should be 3. And here second overtone means N should be 3. Right? Now they are saying that these frequencies are same. So if we talk about the first case, when the second overtone of the closed and the open organ pipes are same, so you will say 2 into 3 minus 1 V by 4L1 must be equal to 3 into V upon 2L2. The lengths must be different, right? So 2 3 is 6 minus 1 is 5. 2 1s are 2 2s are. So L1 by L2 is coming out to be 5 by 6. Okay. Now what they want in the next case is the ratio of the first overtone of the closed pipe. First overtone of the closed pipe means in this formula you have to put n is equals to 2. And third overtone of the open pipe, that means n must be 4. So you will say F1 is 2 2s are 4 minus 1 into V upon 4L1 upon F2 is what? 4 into V by 2L2. So it will become 2 to the 4 minus 1 is 3. 3V by 4L1 and it will be 2V by L2. Now you take the ratio F1 by F2. What will it give you? V and V will get cancelled. So it will be 3 upon 4L1 into 2 upon L2, right? So it will be 3 by 8 into L2 by L1. L2 by L1 will be 6 by 5. Got it? So from here you can get the answer 2 3s are 2 4s are. It is 9 is to 20, right? So third option is correct. Now a person of 80 kg mass. Okay, so here what is happening? This is a disc and sorry, this disc is rotating and this is a person here. His mass is 80 kg and the platform is 200 kg, right? So first of all, since when the person walks and stands here, when the person walks and stands here, then you will say it will rotate with, first it was rotating with n1, next time it is rotating with n2, right? So disc still has mass 2 kg, but this 80 kg man is on the axis, right? And net torque is 0, so angular momentum is conserved about the central axis. So we can say I1 omega 1 equals to I2 omega 2. Omega is directly proportional to number of revolutions per second, so I can write it like this also. I1 n1 equals to I2 n2. Just find out I1. It is 200 into r square by 2 for a disk, mr square by 2, plus for the man it is 80 r square into n1. And what is I2? Sorry. And what is I2? Only 200 by 2, mr square by 2, right? So from here you just equate and then surely your answer will come out to be 9. So you do this, I1 n1 equals to I2 n2. N1 is given already 5 rpm. Clear? Okay. Any doubt? Okay. So I hope you have understood and you can put the values and check your answer, right? This is a very interesting question. See, a bomber flying horizontally with constant speed releases a bomb. So this is the bomber. It is moving with certain velocity and throws a bomb, right? So when it throws the bomb, see, the bomb also gains the velocity v, but at the same time bomb is coming down with certain acceleration, that's all. So what the extra thing that bomb is having is only this acceleration downwards, that's all, right? So the motion of the bomb will be like this with respect to the person on the ground, because the person on the ground will feel that this is accelerated downward and has a linear velocity forward. But at the same time, if you talk about the aeroplane, the aeroplane will always feel that the bomb, because the linear velocity of the bomb will not change and the plane will also not change. So plane will feel that bomb is always below it. That means with respect to the plane, bomb is simply coming down, vertically downwards. So with respect to the plane, with respect to the pilot, both, the bomb is simply coming down right, with zero linear speed. But with the person on the ground, it has some linear speed in the beginning itself, and it has an acceleration downwards, because of which it will look up, it will appear to be a horizontal projectile or parabola. So the path of the bomb as seen by the observer on the ground is parabola, correct. The path of the bomb as seen by the pilot is a straight line, correct. The path of the aeroplane with respect to the bomb is a straight line. So with respect to the bomb also, the path of the aeroplane will be a straight line. Bomb will feel that the aeroplane is going up. Aeroplane will feel that the bomb is coming down vertically. The path of the bomb as seen by the pilot is observed as parabola, wrong. This answer is parabola only if it is observed by the person on the ground. A, B, C are correct. 24. See, for maximum height, the velocity which is responsible is this component uy. Okay, right? So, what is the maximum height? Height is uy square by 2g. So, it is 3 square by 20. So, it is 9 by 20. So, it is 0.45 meter. 25. A stone is projected from the top of a tower with a velocity 20. Okay, perfect. With a velocity of 20 meter per second at an angle of 30 degrees if the total time of flight is 5 seconds. See, we will not talk about all this thing. We will talk only about the vertical motion. So what is uy? Uy is 20 sine 30, that is 10 meter per second. So it goes up and comes down in how much time? In total time of 5 seconds, right? So what is the height of the tower H? Simply you will say, sir, delta y is equals to uy into t plus half into ay into t square, right? Now delta y will be minus h because it is coming down, minus h. Uy will be 10, t is how much? 5 plus half into ay is minus 10 into 5 square. So you can say minus h is equals to 50 minus 125. So minus h is minus 75. So h is equals to 75 meters. Got it? Starting from rest, a wheel rotates with an uniform angular acceleration. Alpha is given 2 pi radians per second square. After 4 seconds, its angular acceleration ceases to exist. Okay, so initial angular velocity is 0. Final angular velocity will be initial angular velocity plus alpha into t. So it is what? Initial angular velocity is 0 into 2 pi into time is 4 seconds. So it is 8 pi radians per second. Now this velocity is constant. So what is the displacement? Now alpha is 0. So you will say delta theta is equals to omega final into t only. Because it is constant, alpha is 0. So 8 pi into next 4 seconds is 32 pi radians. Got it? Now 27. A projectile is thrown at an angle 30 degree with the velocity of 10 meter per second. The change in velocity c. If you throw an object like this, it will go to the topmost point, right? Here the velocity is u. It will be u sine theta here. Okay, I'm so sorry. It will be u cos theta here. Okay, horizontal component remains constant. Vertical component will be 0. Here it is u cos theta and u sine theta both. So if you say what is vector v, it is u cos theta I cap plus 0. What is initial velocity vector? U cos theta I cap plus u sin theta j cap. So if you do the difference, vector v minus vector u will be minus u sin theta j cap. Magnitude wise it is how much? U sin theta. U is 10, sin 30 is half. Answer is 5 meter per second. Question number 28. Two rigid bodies have same angular momentum. Okay, that means same angular momentum means L1 equals to L2. If the same torque is applied, tau 1 is equals to delta L1 upon delta T. tau 2 will be equals to delta L2 upon delta t. If they have same angular momentums and torques are also same, so the time will also be same. So first option is correct. Okay, so what is the relationship V and X? See, V is equals to omega times root over a square minus x square, right? So you will say that, sir, V square is equals to omega square into a square minus x square. Oh, forget it. See, forget this nonsense. We don't want to waste our time. We know that. What is V max? V max is a omega. What is x max? A. What is A max? A omega square. Got it? Now, this is a graph of velocity versus position. So, maximum position means this is your amplitude. So, write down amplitude is 0.1 meter. This is your maximum velocity. That is A omega is 10. So, from here, can you get omega? Yes. 10 upon A. 10 upon 0.1, which is what? 100 radians per second, right? After this, what is acceleration? A omega square. A is how much? 0.1. Omega square is how much? 100 into 100. I guess it is 1000 or 10 to the power 3 meter per second square. Got it? Don't worry, even if it is an ellipse, you don't understand the graph, you can just at least figure out it from the graph now, that when is the velocity maximum, that what does this mean, and what does this mean? This is maximum position displacement, that is amplitude. This is maximum velocity, that is maximum velocity, a omega, right? 30. A string is wrapped. Okay, so this is mg. So they are saying if it comes down by a height of h. Okay, so let's say when it comes down by height of h, its velocity is v, and this is rotating with omega. So the loss in potential energy is mgh. The gain in kinetic energy is kinetic energy of the block plus rotational kinetic energy of the wheel. So moment of inertia is I omega square. And one more thing is V must be equal to R omega because there is no slipping. So equation number 1 and 2, using these two equations, definitely you will get the answer. Definitely you will get the answer. So from here you will say, sir, mgh is equals to half mv square plus what they want is omega. Oh god, they want omega. So don't write v in terms of omega in terms of v, instead write v in terms of omega. So it is r omega whole square plus half I omega square. So you can say mgh is equals to half m r square plus half I whole into omega square. So I guess you can understand, just 2gh upon, yes, 2gh upon, sorry, 2mgh upon mr square plus I under root. Okay, so second option is correct. 31. This thing I want to tell you, students, just remember. Suppose this is the mean position MIPO, this is the extreme position expo, this is also the extreme position expo. Now remember one thing for sure, from here to here, the midpoint, that is a by 2, the time taken is always t by 12, and the remaining half time is t by 6, right? This thing you remember, right? And this complete time is t by 4. Got it? One more thing is, from here to here, t by 8 time, this is always a by root 2. Okay, so in the first t by 8 time, it travels a by root 2, and this distance is what? In the next t by 8 time, it will travel a minus a by root 2. Got it? So I should say like this time period is also t by 8, and this time period is also t by 8, but in the first t by 8 it travels a by root 2, in the second t by 8 it travels a minus a by root 2, and in the first a by 2 it covers, the first a by 2 it covers in t by 12 time, next a by 2 it covers in t by 6 time. So if you remember this data, then obviously this question is easy to solve. Otherwise you can solve it using this equation also. You can say, sir, x is equals to a sine omega t starting from 0. Okay, so phi is 0. So what is x if sine omega is what? 2 pi upon time period. What is the time? T by 8. You put it like this, right? So it will be pi by 4. So x is equals to a sine pi by 4. Pi by 4 is 1 by root 2. So you can say x is equals to a by root. So either you can do this, but it is better if you remember this data because it is a really important date. Okay, it's up to you now. 32. Third option is correct because time period is 2 pi root over m by k, spring mass system. It doesn't depend upon gravity. So third option is correct. 32. So length of a sonometer wire. So what they are saying is that this is fixed at both ends. So where should we keep these holders? So this is L1, this is L2 and this is L3. See, one string, one frequency. So the frequencies are same. But the only thing is that they are oscillating in different modes. Right? This is oscillating in different mode. This is oscillating in different mode. This is oscillating in different mode. So we will say that F is equals to, okay, the length of the sonometer wire is 100 centimeter. Where should the two bridges be placed? From A to divide wire in the three segments whose fundamental frequencies. Okay. Fundamental frequency for the first case will be V by 2 L1. Okay. V by 2 L2. Fundamental frequency will be V by 2 L3. Right. So we will say that F1 is to F2 is to F3 is equals to 1 by L1 is to 1 by L2 is to 1 by L3. So it is 1 is to 2 is to 3 is equals to 1 by L1 is to 1 by L2 is to 1 by L3. So it is right. So we can say L1 is to L2 is to L3 will be how much? 6 is to 3 is to 1, right? So what is L1? L1 will be 6 upon 10 into 100, right? And this is at a distance L1 plus L2. So L2 is what? 3 upon 10 into 100. So this is 60 centimeter and this is 30 centimeter. But wait. This bridge is at a distance of 60 centimeter. This gap is 30 centimeter. So next bridge is actually at a distance of 90 centimeter. So your answer should be 60 and 90, not 60 and 30. Okay. Second option is correct. 34. This is a good question. What we can do is see an object drops from a certain height. So it reaches the bottommost point in how much time? If u is 0. So time is root over 2h by g. Okay. And in 1 second before, so in the last 1 second it covers 0.36 h. So what is the distance it covered in t minus 1 time? In t minus 1 time it covered 0.64 h. Yes. So we can say delta y is equals to ut plus half at square. U is 0 anyways. Ut plus half at square. U is 0. Delta y is minus 0.664 h. Minus y because it is downwards. 0 plus half into minus g into time is how much? T minus 1 square. Right. So you can say 0.64 into 2h by g is equals to t minus 1 whole square. Now 2h by g is t square. So 0.64 into t square is equals to t minus 1 whole square. So on solving we can get t is equals to how much? 0.8.25 seconds. So time is coming out to be 5 seconds. So obviously now h is what? Half gt square from this equation. H is half gt square. So half into 10 into 5 square. What is the answer? 125 meters. Got it? Fourth option is correct. 35. The vibrations of a string fixed at both ends. See, it is 2a sine kx cos omega t, right? So what is k? K is 2 pi by lambda is equals to pi by 15. Pi and pi gets cancelled. Lambda is 30 centimeter and lambda by 2 is 15 centimeter. Okay. So in standing waves, these gaps are lambda by 2. Okay. So when we are talking about 2 points, so what happens? All these particles here have gone up, yes, and all these particles here have gone down, and again all these particles here have gone up. Okay, now remember, the particles of the same segment don't have any phase difference. They go together up, they come together down, right? They come down together, they go up together. But when I talk about the particles of two adjacent segments, then what happens? This is an interesting case. See, one particle is at 13 centimeter. This is the point x is equals to 15 centimeter. This is the point x is equals to 0 centimeter. So one particle is at 13 centimeter, let's say this A. Another particle is at 16 centimeter, let's say B. So what is the phase difference between them? One is going up, at the same time other one is going down from the same spot. That means their phase difference is pi. Got it? If B would have been here in the same segment, then delta phi would have been 0. Right? Clear? 36. This is simple. What is the frequency? Frequency is n by 2l into v is t by mu. So f is directly proportional to root t and L. Okay, so like this, we can say F1 upon F2 will be root over T by L into, now the new tension is 1.21, sorry, new tension is, let's say, root T by L. So we can say T by T dash under root into L dash by L. So it is 1 upon root over 1.21 into L dash will be what? Decreased by 45%, so 0.55 L1, na? So it will be 0.55 upon 1. It is 1.1. So F1 by F2 will become 1 is to 2, right? So on solving, we can say F2 is 2F1. That means increment is of 100%, right? 37. Negative x direction. The wave is propagating in the negative x direction. That means this is wrong, this is wrong. Either second option or fourth option. Amplitude is 0.5 meter. Yes, amplitude is 0.5. Amplitude is 0.5. Now, wavelength is 1 meter. So this is also same. So we need to compare only with the help of frequency. What is frequency? Frequency is F. It is 2 hertz. And what is omega? 2 pi F. Right? So it is 2 pi into 2, that is 4 pi. So omega is 4 pi, that means second option is correct. 38. See, this is a rod. From this axis, it is ml square by 12. Right? Even if you fold the rod like this, about the central axis, the distribution is not changing. Right? The distribution about the axis is not changing. Right? It is in the same plane, the distribution is not changing, so hence the moment of inertia will not change. Otherwise, if you want to do, you can do it like this also. You will say this is m by 2, this is m by 2, this is L by 2, this is L by 2, right? So you can say moment of inertia will be 2 times 1 by 3 of m by 2 into L by 2 whole square. You solve it, you will get this answer only. Okay? This is very simple. What is the velocity here? Find out. So you will say, sir, half mv square is equals to mgh. So from here you will say, sir, mv square is equals to 2 mv square by, let's say this is r, this is also r. So instead of writing r, h, we can say mvr, right? So mv square by r is 2 mg, equation number 1. This is the height by which it has fallen. Number 2, here what is the tension T upwards, mg downwards? Is it accelerated? Yes. So T minus mg is MAC, which is mv square by r, and mv square by r is 2 mg. So tension is 3 mg. Got it? This option is correct. A particle is projected from a point on the ground, making an angle of 30 degrees with the horizontal. See, it's very logical. A particle is thrown from here with a certain velocity at an angle of 30 degrees. So it goes here and here. Right. So this is T1 is equals to 2 seconds. This is T2 is equals to 4 seconds. So obviously this time will also be 2 seconds. That means T1 plus T2 is nothing, actually total time of flight, which is 6 seconds, right? If it is at the same height, right? Then the speed of projection is, see, we know that time of flight is 2uy by g. So 6 is equals to 2 into u sine 30 by 10. So 2 ones are, and sine 30 is half. So u is equals to 60 meter per second. An 8 kg stone tied at the end of a string 2 meter long whirled in a vertical circle at the instant when the string makes an angle theta with the vertical. Very simple. Let's say this angle is theta. This is mg. This is mg cos theta. This is centripetal acceleration. This is tension. T minus mg cos theta is equals to MAC. So T is equals to mg cos theta plus mv square by r. Everything is given. Everything is given. M is given, R is given, theta is given, right? If tension is given, everything is given. You put it, solve it, you will get cos theta as half. So theta is 60 degrees. Got it? 42. We know that time period of a pendulum is 2 pi root over L by G. So delta T by T is half times delta L by L if G is constant. So percentage change in time period will be this. Half into delta L by L is alpha delta theta into 100 percentages. Got it? So half alpha delta theta into 100. Alpha is 2 into 10 to the power 6. Delta theta is 10 degrees centigrade. Put it, your answer will be fourth option. 43. We know the formula for velocity. It is how much? Root over bulk modulus upon density, right? So it is v square into rho is equals to bulk modulus. This is the formula you have to use. Be very careful. It is 5.4 kilometer per second. So don't forget to convert kilometer into meter and gram per centimeter cube into kg per meter cube, right? I will express it. 5.4 kilometer means per second means 5.4 into 10 to the power 3 meter per second, and 2.7 grams per centimeter cube means 2.7 into 10 to the power 3 kg per meter cube. Got it? Put in the formula, get the right answer. This is the condition that if suppose two rods are given, whenever two rods are given and they say one rod is of length L1, alpha 1, length L2, alpha 2. If this difference delta L is constant, we can say L1 alpha 1 is equals to L2 alpha 2. Remember, okay? Just remember this case. If you want to get it, it's easy. We have done it in the previous exam also. I have discussed this thing, that L1 minus L2 is constant. That means L1 minus L2 is equals to L1 dash minus L2 dash, right? So we can say that L1 dash minus L1 is equals to L2 dash minus L2. So it is L1 alpha 1 delta theta, L2 alpha 2 delta theta, and this will get cancelled, and L1 alpha 1 is equals to L2 alpha 2, right? Same concept here has been applied. They are saying that a thin brass sheet. So let's say this is a thin brass sheet here, and this is also whatever it is. So their areas are equal right now, right? And they are saying that there is one more temperature where their areas are equal again, right? Okay. Let's say this is A1, this is B1, this is A2, this is B2. So they are saying A1 B1 is equals to A2 B2, right? And A1 dash B1 dash must be equal to A2 dash B2 dash, right? Whenever this is the case, remember always, you can say again beta 1 A1 is equals to beta 2 A2. Okay. Not sorry, not this case. Let's solve it. Okay. So what is A1 dash? A1 dash is A1 into 1 plus alpha 1 into delta theta 1, right, into b1 into 1 plus alpha 1 into delta theta 1, got it, must be equal to a2 into 1 plus alpha 2 delta theta 2 into b2 into 1 plus alpha 2 delta theta 2, got it. So a1 b1 a2 b2 will get cancelled. A1 B1 as a product, A2 B2 as a product will get cancelled, right? So we can say 1 plus alpha 1 delta theta 1 whole square must be equal to 1 plus alpha 2 delta theta 2 whole square. Now we can take under root, no problem, 1 will get cancelled out. So final answer will be alpha 1 is how much? 19 into 10 to the power minus 6. Let's say at a temperature T. So T minus 20 is equals to 11 into 10 to the power minus 6 into T minus 30, right? After you solve this, your answer will come out to be minus 3.75 degree centigrade. That means at this temperature again their areas will be equal. Now, net acceleration of a particle in circular motion is always along the radius? No, because net acceleration is centripetal plus tangential. Only centripetal is along radius, tangential is not. So this is wrong. Velocity is always tangential, yes. So only B is true, A is false, right? What is the time period? 2 pi root over m by k. If the mass is increased by 1 kg, plus 1 by k, now you take the ratio. T1 is 2 seconds, T2 is 4 seconds, root over m upon m plus 1. So 2 ones are 2 twos are 4, 1 by 4 is equals to m upon m plus 1. So m is 1 by 3, right? 48. Very good. See, they have given you initial velocity vector, it is 10 j cap. They have given you acceleration vector 8 I cap minus 4 j cap. Displacement after 2 seconds. See, what is this displacement vector? Vector u into t plus half into vector a into t square. So it is, time is how much? 2 seconds, right? So it is 20 j cap plus half into 8 I cap minus 4 j cap into 2 square, cancel. So delta r vector will become 20 j cap plus 8 I cap, sorry 8 2s are 16, right? Plus 16 I cap minus 8 j cap. So it will be 16 I cap plus 12 j cap. So overall displacement will be, magnitude will be how much? 16 square plus 12 square under root, that is 20 meters. Got it? Okay, so they are saying, see, what is the range when the velocity is 20 only? Range is u square sine 2 theta by g. Sine 45 into 2 is 90, sine 90. So u square into 1 by g. What is u? 20 whole square by 10. Answer is 40 meters. Got it? Now, if your velocity is greater than greater by 5%, so that means u1 is like 20 plus 5% is what? 1. That is near about 21 meter per second. And u2 is 19. So 20 minus 1, that is 19 meter per second. So obviously the range r1 is near about 44.1 meters and r2 is near about 36 or something like that. Okay, 36 something like that. Okay, so obviously which of the following is out of our range? 45. This is very simple. Yeah, see, beta plus density. So beta must be having the formula of dimensional formula of density. Then alpha is beta into force. So alpha must be having the dimensional formula of density multiplied by force. I guess you can do this question. There is no need to discuss this question, right? So that is all for today. Subscribe to our channel, students, and there are videos being uploaded on different topics of 12th and 11th standard in one shot. Also, we are discussing previous year question series also. Okay, so stay tuned to our channel, subscribe to our channel, because you subscribe, we thrive. Okay, thank you so much. Tada, bye bye, good luck for your next examination as well.